We're going to talk about perfect competition in this chapter. And as you recall from the last chapter, we kind of had a continuum with the number of firms. With one firm, remember that's a monopoly. And, well, we'll say zillions. Okay, that's perfect competition. When we have a few firms, a few large firms, that's an oligopoly. And lots of, well, we'll just say lots of firms, that's a monopolistic competition. So we're going to start over here, perfect competition, zillions of firms over on this extreme. Then in the next chapter, we'll go clear back over here on this extreme. Then we'll pick it up in the middle. So let's lay this out. Here we're going to have the market supply and demand curves. And we'll say this is for wheat. Okay, and that is market for the entire market. So this is the supply of wheat. This is the demand of wheat. When this supply curve represents all zillion firms, this demand curve represents all zillion consumers buying wheat. Over here, right next to it, well, I'll get fancy with the colors later. We're going to have the the curves for the firm. Okay, so here is the entire market. This is the firm. One little measly farm in this case. And we'll say this is Farmer Jones. Got him a wheat farm. They're out in Kansas or somewhere. Now Jones, remember when we're talking perfect competition, we're talking a lot of firms. They're basically identical. They're small, relatively small firms, or at least they're small relative to the market. That's the main thing. So an individual firm is too small to have any impact. See, Jones, no matter how much Jones produces, or if he goes out of business, this supply curve stays right there because Jones is one of a zillion tiny parts of this supply curve. So Jones is a price taker. This equilibrium price right here, we'll say is $10. I know that's a pretty good price for wheat, but that line right there, that is the price for Jones. So it doesn't matter how much Jones produces. He could produce way out here. He can sell it for $10. If he produces this much here, he can sell it for $10. It stays at $10 because it doesn't matter, again, how much or how little Jones produces. It's not going to affect this supply curve because he's too small relative to the entire market. So when Jones looks at this price at $10, he says, I can sell all I want for $10. He is a price taker. Okay, he just looks at this price and he has no power over it. Okay, well, what else have we got here? This is the price. This line here is the price. But let's see what else it might be. Let's put quantity here, price here, total revenue. Okay, so price times quantity times price equals total revenue, right? Quantity times price, price times quantity. And marginal revenue here. Remember, marginal revenue is the change in total revenue divided by the change in output. Well, let's see what we've got here. Let's see, we've got 1, 2, 3, 4. Well, let's make it 5. And the price, what is the price? If Jones produces 1 unit, 2 units, 3 units, 4 units, 5 units, again, the price is 10. It's always 10. Doesn't change from 10. Again, he's a price taker, has no power over the market, he's too small. So if he produces 1, he gets $10. 3, it's $10. 4, it's $10. Get $10. Total revenue, 1 times 10, it's 10. 2 times 10 is 20, 30, 40, 50. Marginal revenue, change in total revenue divided by change in Q. Well, let's see. Q goes from 1 to 2, and total revenue goes from 10 to 20. So let's see. Change in Q is 1, and change in total revenue is 10. Marginal revenue is 10. Now we've got quantity going from 2 to 3, a change of 1. Total revenue going from 20 to 30, a change of 10. 10 divided by 1 is 10. And then we've got quantity going from 3 to 4, a change of 1. Total revenue going from 30 to 40, a change of 10. Marginal revenue 10. And we got the same thing from 4 to 5, revenue going from 40 to 50, marginal revenue is 10. So, marginal revenue is also 10. So we've got, I don't want to change the colors. It makes it look like I'm trying to color code something, and sometimes I am trying to do that, but this is not one of those times necessarily. So you're going to be scratching your head and say, what the heck? Okay, so this line here is the price that Jones can get, and it's also his marginal revenue. But don't stop there. Average total revenue. Well, average total revenue is total revenue divided by Q. Okay, so total revenue, 10 divided by 1. Well, let me write it in here. Okay, 10 divided by 1. 10 divided by 1, average revenue is 10. And then we have 20 divided by 2. $20 divided by 2 is 10. And 30 divided by 3 is 10. $40 divided by 4 is 10. 50 divided by 5 is 10. Okay? So, well. This is not only the price, it's not only marginal revenue, but it is also average revenue or average total revenue. Okay? And it's one more thing. This line here is also Jones's demand curve. Jones, this is the demand curve for Jones's wheat. Okay, here's the demand curve for wheat. Wheat, period. Okay, this is the demand curve for Jones's wheat. Jones has a perfectly elastic demand curve for his wheat. Why? Why? What will happen if Jones decides to raise his price up to $11? Is anybody going to buy Jones's wheat? No, nobody, absolutely nobody will buy Jones's wheat. Because they can go to Smith's wheat next door and buy his wheat, okay? Or they could go to Nebraska and buy Nebraska wheat. Remember, there's a zillion of these guys. There's a zillion Farmer Joneses out there. And their wheat is considered to be, at least by the market, believed to be identical. You can't tell Jones's wheat from Smith's wheat, from Robert's wheat, from, okay, you can't tell the difference. It's all wheat. It's just wheat. And so there's no market power. Remember, there's a zillion Farmer Joneses. They all produce an identical good or service, a homogeneous, right? So if Jones raises his price, he loses all his business. Nobody's going to buy his wheat because nobody thinks his wheat's any better or any different in any way. And on the other hand, why would he lower his price? He can sell all he wants at $10. There's no reason to lower it. Why would you lower the price? He can already sell as much as he wants because he's teeny tiny in the market. He can sell all he wants at 10. No reason to lower it below that. And if he raises it above that, he loses all his business. So a perfectly elastic demand curve for Jones's wheat. The next question, well, the question we want to answer, I should say the first question we want to answer here, is how much will Jones actually want to produce? We said that he can produce all he wants at $10. How much will he choose to produce? Now, to answer that question, we're going to need our cost curves. Remember these cost curves from the last chapter? We've got average total cost, average variable cost, and marginal cost. Here's our average total cost. Here's our average variable cost. And here's our marginal cost. Okay, we've got our revenues right here, marginal revenue, average revenue. Now, to do some analysis here, we're going to match marginal revenue with marginal cost. That's where we will decide how many units, or Jones will decide how many units he's going to produce. Those kinds of decisions are made at the margin, that last unit produced. Whether or not Jones makes a profit, well, we're going to match average revenues against average costs. Okay, and then later, whether Jones shuts down or stays open, we're going to match average variable costs. We're going to take a look at average variable costs to answer that question. So, let's move. I'm going to move these curves over one by one. Let's first find out what Jones is going to produce, if he produces at all. Okay, he may decide not to produce at all, depending on the price, depending on what his costs are. But if he produces, this is how much he'll produce. I will draw in our marginal revenue curve, our marginal cost curve. Okay, there's our marginal cost curve. And let me get rid of this. We don't need any of this. Just drew that in there to bring back the good memories of the last chapter. Didn't want you to think we forgot about those. Okay, so let's say, well, let's give this some numbers. 30, 40, let's see, that's 20. Okay. All right. Let's say you threw some darts at this graph, and a dart hit on number 20. It hit right here. Is that a good place for Jones to produce? Well, here is Jones's marginal cost. Yeah, let's give that a number. Let's say that's 8. No. Let's go lower because I'm going to need some more numbers. Say that's 5. And at 20 units, his marginal revenue, well, we know what that is. That's 10. Okay. So the 20th unit produced brings in a marginal revenue. It brings in revenue. That 20th unit adds $10 of revenue. That's what marginal revenue is. It's that last unit produced. And the last unit produced, that 20th unit, adds $5 to costs. Should he stop there? Should he produce some more? Well, let's see. Let's go one more. Let's say he produces 21. Let's just say that's 21. At 21, the marginal cost is $6. That 21st unit adds $6 to costs and adds $10 to revenue. So the marginal cost is 6. As we've gotten here from the marginal cost curve. The marginal revenue is always 10 here. Well, that was a good decision to produce the 21st unit. In other words, if he doesn't produce that 21st unit, he's leaving money on the table. So of course you're going to produce the 21st unit. Think of it this way. Would you be willing to give someone $6 in exchange for $10? Well, of course. Here's $6, buddy. You give me 10. That's a good trade. So that's what you're doing by producing the 21st unit. You're giving up 6, getting back 10. I'll make that trade anytime. Let's go on to the other side. Well, the other side. I'm giving it away. What am I talking about, other side? Forget I said that. Let's go over here to 40. At 40 units, marginal costs are way up here. Okay, let's say that's, let's just say that's 20. Well, the 40th unit, you produce the 40th unit, and the 40th unit you get, what do you get for that? What's your marginal revenue? Well, your marginal revenue is just equal to the price there. Your marginal revenue is 10. So you're bringing in 10, but that 40th unit, you had to give up 20. So how many of you would say, hey, pal, I've got $10. Excuse me. Hey, let's try that again. Hey, pal, I've got $20 in my pocket. I'll give it to you if you'll give me 10. Well, that's not very good either. So we're leaving money on the table here with the 20th unit, 21st unit. Over here, well, the added costs are more than the added revenues. So what you're going to do, this is how it's going to work. As long as marginal revenue is greater than marginal cost, you're going to keep on increasing production till right there where they are equal. So marginal revenue is greater than marginal cost all the way to right there. You'll stop there. You're going to produce the 30th unit. You won't produce the 31st. You'll stop at 30. Why? Because the 31st, you're adding more to cost than you are to revenues. So the firm, a profit maximizing firm, will produce the quantity where marginal revenue equals marginal cost. At that point, their profits will be maximized, or their losses will be minimized. We don't know if they're making a profit yet. All we know, why don't we know? We're going to have to use average revenues to figure that out. We're not there yet. We don't have an average revenue curve over there. Excuse me, we have average revenue. We have average revenues. We need to know average costs. So we can figure out our profit per unit, and then we can multiply by the number of units to figure out the profit. But no average cost curve here yet. So we know how many units the firm will produce if they produce. Something we're going to talk about later. If they produce at all, they're going to produce 30. And they'll either be making a profit, they'll either be maximizing profit or minimizing losses. Okay. Next, we want to figure out if Farmer Jones is making a profit or not. Now we're going to bring our average total cost curve over. Remember, that's going to be coming down, and then it's going to be rising. Okay, if I drew that right. So we see as long as marginal cost is below average total cost is falling. When marginal cost goes above average total cost is rising. So it comes down, marginal cost cuts through the bottom, goes up. Okay. So we know that Jones is going to be producing 30 units if he produces at all. At 30 units, we see his cost per unit is, let's say that's 8. And then, of course, the revenue per unit, or average revenue, that's what average revenue is, revenue per unit, average total cost, cost per unit. Okay. And we already know that, well, that's not a very, okay, let me, at 30 units, the revenue per unit, of course, is equal to price, which is equal to 10. So, profit per unit equals average total revenue minus average total cost, which is equal to 10 minus 8. That's 2. So profit per unit produced is $2. So what is total profit? $2 per unit times the number of units, which is 30. Okay. Profit is $60. You could also do it this way. Well, you could also figure out total revenue minus total cost equals profit. Okay. Well, what's the total revenue? Well, total revenue would be average revenue times quantity, right? This is revenue per unit times the number of units. So that is 10 times 30. So revenues are 300. 10 times 30 is 300. Total cost. Well, we have cost per unit here, average total cost, and that we know that's 8. Cost per unit is 8. Total cost would therefore be total cost per unit times the number of units. Average total cost times Q. So 30 times 8 would be our total cost. So profit is 60. 300 minus 240. So different ways to do it. Profit is just total revenue minus total cost, or profit per unit is average total revenue minus average total cost. And then from there, you could multiply that by Q to get the total profit. So anyway, you can see that all the information is here to get a bunch of different answers, a bit different information. Now we're going to look at the behavior of firms in a perfectly competitive environment. And what I'm going to show you is why there are 0 economic profits in the long run. In a highly competitive industry, you are not going to hold on to those economic profits long term. And the reason is, in a perfectly competitive market, there are no barriers to entry. That's the biggest thing. Firms can enter and exit. And what's going to happen here? What's going to happen here? Got some brand new fresh curves here. Well, the first thing we need to look at is where the firm will produce. Where are they going to produce if they're going to produce? They're going to produce right here, where marginal revenue here equals marginal cost. So that, we'll just put Q star there. That is the level of output for this firm. And are they making a profit? Well, yes, they are. We can see this is average revenue right here. So average revenue is up here, and average cost is right here. So this difference is their profit per unit. Now, remember, we're talking economic profits. Economic profit means you're better off doing what you're doing than you could be elsewhere. And so, in our little example with wheat, I know this is far-fetched because nobody gets rich on wheat, I don't think. But let's just suppose we're here and this Farmer Jones guy is making a killing. He's making an economic profit, and everybody is looking at Jones, and Jones has got the fancy horns on his car, and he's got the steer horns and wearing fancy cowboy boots, a whole bit, and they're thinking, man, Jones is, what's going on? Well, yeah, he's over there growing wheat. Well, what are the corn farmers going to do? They're going to start planting wheat too. There's going to be entry into this market. And what that does, when there's entry into a market, that means the supply curve is going to be shifting out to the right. And it's going to keep shifting until those economic profits are gone. So, where's the firm going to produce now? See, the entry into the market has made the market price go down, and each individual firm is a price taker. They have no power over this. But as the supply of wheat has increased because of more entry into this industry, the price has fallen. And so this is our new price line, price, marginal revenue, average revenue, and demand curve. So where is the firm going to produce now? Well, again, it's going to be where marginal cost equals marginal revenue. So it's going to be right here. So let's, we don't need that anymore. So what's happening here? What's happened to profits? Well, we have average revenue right here. This is average revenue. And we have average costs right here. So average revenue equals average costs. 0 profit per unit, 0 total profit. Now, we're talking economic profits. They are still going to be making an accounting profit. Okay, their actual revenues coming in are going to exceed their costs, but the implicit costs aren't there. They're usually buried into the fixed cost. Okay, and we can get fixed costs anytime we want by taking the difference between average total cost and average variable cost, which we don't have on here yet, so we're not going to worry about that yet. So just keep in mind that they're actually making an accounting profit. On their income statement, it's going to show a profit, but it's only going to be the amount of profit that they could get elsewhere, and therefore they're not any better off nor worse off than they could be elsewhere. Okay, now let's suppose that some new research comes out and that says wheat takes 10 years off your life. It's bad for you. It's harmful. Well, what's going to happen is the demand curve is going to shift back to the left. And we've got a new price here. And what's happening now? Here's price equals marginal revenue equals average. Okay, you got the idea. Now, if the firm's going to produce, again, the first thing you do, find where marginal revenue equals marginal cost. And keep in mind that marginal revenue equals the price under perfect competition. So, well, I'm on the wrong curve. Here's our new price and marginal revenue. And the firm here, if they're going to produce right here, where they are equal. Now what's the situation? Well, here's average revenue, but up here, here's average cost. Well, let's write that in. Average total costs are up here, average total revenue's here. Cost per unit is bigger than revenue per unit. They're losing. They've got negative economic profits. Now, they very well may have positive accounting profit here, but it's not as big a profit as they could get elsewhere. So they've got negative economic profit. They're not as well off as they could be elsewhere. Well, if you're not as well off as what you could be doing elsewhere, you're not going to stay there forever. Okay, you're eventually going to make a change. But in the short run, maybe not. Probably not. Okay? In the long run, yes. In the short run, they're just going to have economic losses. So, what's going to happen here is ultimately firms will leave the market, and we're going to go back. Well, let me get rid of those. Okay, there we are right here, the current equilibrium. And ultimately, firms are going to leave the industry. We're going to have the supply curve shifting back to the left until we have, well, about right there, until we're back here again at zero economic profits. So this is the mechanism by which firms adjust Firms enter and exit an industry, and that's why negative economic profits are not going to be long-lasting over the long term. Positive economic profits not lasting over the long term. The industry, the market will adjust, but in the long run, you're not going to have more than zero economic profits. That's the long run equilibrium, is zero economic profits. Because if there's positive profits, that will attract firms into this industry and they will be competed away. If there are negative economic profits, firms will leave the industry. Now we see this all the time in college majors. Students pursuing the major that, I'm not saying every student does this. Some students, they know darn well their major is not going to pay very much, but they love it so much that they're willing to take that risk. But at the margin at least, say mathematics majors, they see, I've seen this over the years. There was an engineer boom years ago when there was a shortage of engineers, and because of that, the wages got bid up quite high. And so other majors, maybe similar to engineering, but they had the same mathematical skills and so forth. They would change their majors. They'd look at all these engineering graduates going off and making big bucks. They say, well, wait a minute. Maybe I'll go to engineering, and they did. So money, and as a result, as more and more people majored in engineering, that if the supply of engineers increased to the point where that wage differential wasn't, kind of leveled off. So, money attracts. Money sends a signal. When you've got high prices, or high profits, I should say, economic profits. So an engineering graduate is making an economic profit over and above what he or she could have made doing mathematics. That's not going to stay forever. As more and more students major in engineering, that kind of goes away. So, but we see that. We see that as people change their majors, go into different fields. They take different jobs. They're attracted by the economic profits that they can make. That's how a market system works, by efficiently allocating resources. I just read something in the paper today, someone alleging that the belief of the market system or capitalism is that resources are distributed fairly. No, not necessarily. Maybe it's fair, maybe it's not. Again, the word fair has a million different meanings. Now, does it distribute it equally? See, that's a different word, equally. No. In a market system, those who produce the most get the most. Okay, that's the way a pure market system works. Now, we have a system where we do have a lot of social programs to help people out. And so it's not just survival of the fittest, but those who produce the most get the most, and they're attracted by market signals such as economic profits. So, but in the long run, as things adjust, economic profits are zero. They don't stay forever. And I experienced this myself. I was one of the first ones in online teaching, for example. I think I had, I don't know if I had the first online class during the winter term or not, but I was one of the first. This was back around 2005 or 2004, or somewhere in there. And I had a winter course. It's called The Economics of Poverty and Discrimination. I don't teach it anymore because the book went out of print. Believe it or not, in this day and age, with so much interest in equality and all that, there are no textbooks. The market-leading textbook is not being renewed. It went through 11 editions, and it's gone now. But anyway, I replaced it with a kind of similar economic issues. Okay, I do that one now, and that's a little more broad. It's not as specialized in one area, but it focuses on current economic issues. Anyway, because I was one of the first, not just on this campus, but anywhere, I had students. Well, first of all, I taught a couple of sections, and I had students from all over the country. Usually athletes who needed to keep their eligibility. They needed a class, between semesters. But my goodness, I was pretty popular nationwide. Is that the case today? Unfortunately, no. No. Other professors around the country saw this activity, and what did they do? They developed their own online courses, okay? So it inspired entry into that field. And I don't have the market power or whatever I enjoyed for a little bit is long gone. So, market signals. Very powerful, very powerful.